In the previous video we have already seen what are the damped vibrations. Now in this video let us see some of the problems on the damped vibrations. The first question is, what is the critical damping coefficient? The critical damping coefficient is nothing but that one we are calling as Cc, which is equal to 2 into m into omega n. Derivation of this one Cc for critical damping coefficient, you can watch my previous video. This 2m omega n is nothing but 2 into m into omega n is nothing but square root of k by m. This can be written as square root of 2 into square root of m into k. This is called the critical damping coefficient. So the option is B. The next question, what is the damping ratio? The damping ratio is nothing but zeta. We are calling zeta is the ratio of the damping coefficient to the critical damping coefficient Cc. This can be written as C by Cc. We have just now we have seen as 2 root km. So the option is D here in this case. Next question is, what is the natural frequency of the damped vibrations? Natural frequency of damped vibrations omega d can be written as omega n into square root of 1 minus zeta square, which is the damping ratio whole square. This can be written as omega n is nothing but square root of k by m into square root of 1 minus, it is c by cc whole square, c by cc. C by cc is nothing but 2 root km whole square. This is nothing but square root of k by m into square root of 1 minus c square by 4 km. This is nothing but square root of 4 km minus c square by, this will become 2m. Root k will be cancelled, root m and root m will become m, and root 4 is 2 here. So the option is B here in this case. Now the next question is, what is the logarithmic decrement? Is nothing but, we are calling log deq, is 2 pi zeta by square root of 1 minus zeta square. This is nothing but 2 pi into zeta is nothing but c by cc. Cc is 2 root km into square root of 1 minus zeta square is c square by 4 km. Right. This is nothing but 2 pi c by 2 root km into square root of 4 km minus c square by 2 root km. This is nothing. This can be equated as 2 pi c by square root of 4 km minus c square. So option A is the right option. Now let us see the next question. Match the following. It is critical damping, over damping and under damping. On the right side we have roots of the auxiliary equation: unequal and imaginary, equal and real, unequal and real. In the previous video we have already seen that the roots of the auxiliary equation S1 and S2 are given by S1 comma 2 is equal to omega n into minus zeta plus minus square root of zeta square minus 1. For the critical damping case, zeta is equal to 1. We know that if we place zeta equal to 1 here, this term will become 0. So for S1 S2 values we will get the equal values, and in this case if zeta equal to 1, S1 2 is equal to minus omega n. It will become minus omega n, and that means the roots are real in this case, no imaginary terms, real and equal, real and equal. So A is matching to the 2. Next one, the over damping case. Over damping means zeta is more than 1. Zeta is more than 1. If zeta is more than 1, this term will become positive. This term will become positive, and we are having plus minus here. So here we will get S12 as unequal but real, because there is no negative term inside the square root. So this number will be a real number, and S1 is minus zeta plus square root of zeta square minus 1, and S2 is minus zeta minus square root of zeta square minus 1, as the roots are unequal and real. So over damping, unequal and real, this one like this. So B is matching to 3. The third case, under damping, zeta is less than 1. When zeta is less than 1, we are getting this term as negative. Inside square root we are getting negative, so we are getting imaginary term here, and the roots are also unequal because S1 and 2. S1 is minus zeta omega n plus square root of zeta square minus 1, and S2 is minus zeta omega n minus square root of zeta square minus 1. These two are unequal and imaginary. imaginary because we are getting negative term here in this case. When zeta is less than 1, this term will become negative. So we are getting I term here in this case. So unequal and imaginary. Unequal and imaginary. So C is going with 1. C is to 1.